Okay, hello folks. Today will be our sort of last lesson for the unit. And it's not really even anything new. It's just kind of putting everything together that we've been doing over the last 2 weeks or so. And then what I'll do is when I give you the handout sort of homework problems, I'll have those posted at the end of the day today. And then tomorrow, which will be Wednesday, I believe. I always get confused because I do it a day in advance. I will post some review, and then the solutions to the review will go up later this week, and then your test will go up at the start of next week. So make sure that you've worked through some stuff and asked some questions before the test goes up, because obviously once the test is up, I'm not going to answer questions about questions on the test, unless they're a clarification question. Okay, so here's your first 5-minute question. Write a quadratic relation in standard form with no zeros. I would like you to pause and try that. Okay, so there are a few ways to go about this. The way that I was hoping you would do it is to work with the discriminant. And remember from yesterday that if the discriminant, that's the part under the square root sign in the quadratic formula, is less than 0, then our equation will have no zeros. So check this out. I'm just going to say, let's say b equals 10. So 10 squared minus 4. Let's have a just be 1. And let's not do c yet. It's less than 0. So 10 squared minus 4 times 1 times c, so minus 4c is less than 0. So if you check this out here, basically, if we have 10 squared, that's 100. So 100 minus 4c is less than 0. We just have to put a number here for c that will make this whole thing be less than 0. Let's put in 1. This will be 100 minus 4. That's a lot bigger than 0. So let's put in like 20. So 100 minus 4 times 20, 100 minus 80, still greater than 0. Let's put in 60. So 100 minus 4 times 60. We want it to be less than 0. 100 minus 6, 12, 18, minus 240 is less than 0. And we get negative 140 is less than 0. That's true. Okay, so we have our values. Now you could have done this a whole bunch of other ways. This is just the first way that came to mind. So A we said was 1, B we said was 10, and C we said was 60. So that means that y equals 1x squared plus 10x plus 60 should be an answer that we want. Let's see. X squared plus 10x plus 60. X squared plus 10x. Whoa, it's not good so far, right? We've got 2 zeros there. So we're going to shift this thing up by 60, and all of a sudden I can't see it because it's way up here. So let's see. What if we did plus 30? That would be fine. Plus 40. Obviously that would be fine. Plus 20. Well, remember we saw that 20 wouldn't work. What about 25? Oh, that's got 1 0. What about 26? And there you go. That one wouldn't work either. So there's a ton of ways to do this. The other way I was going to say was to start with a vertex form. So let's say y equals 2x minus 4 squared. So I've got a parabola that opens up. And remember, if we put it above the y-axis by making the k value positive, remember if a and k are both positive, no zeros, and then you would double up x minus 4, FOIL, multiply through, and collect like terms. So you could have done it that way as well without any of this sort of guessing and checking that I did here. All right, here we go. So like I said, today's not a new lesson. It's sort of putting everything together from the whole unit. So what we're going to do is we're going to fill in this table, and then we will solve some problems. All right, so I went into the Word version because it'll be easier for me to type things. I'm going to make the font size a bit smaller. Okay, so we've got standard form here. So this is standard form. Okay. And make both of these centered. This is obviously vertex form, vertex form. And this one here is factored form. So these are 3 types of equations. Very important that you know the 3 different types. Okay, and then for this, I'm going to just have it regular old like this. All right, so what can we see from standard form? Well, A tells us the, let me put a little dash there. A tells us the step pattern and direction of opening. And I'm going to copy and paste this into the other 2, because obviously A is in all 3 of them, right? Okay, now let's sort of do what's different between them. So C tells us the y-intercept. This is going to be a really handy little table if you take the time to fill it out. That will sort of help you as you move forward in this unit, and it'll be a good thing to hang on to for next year as well. If you plan on taking 3U or even 3C, you do this stuff in 3C as well. All right, so H comma K is the vertex, and then here R and S are the zeros, and that's really all I needed for this. Okay, let me sort of do a little centering here, make them look a little bit prettier. Give a little bit of space. Okay, examples. How can I change to a different form? So what that means is, like, how do I go from standard form to vertex form, or how do I go from standard form to factored form? So 1. To go from standard form to vertex form, you would complete the square. To go from standard form to factored form, you would factor, if possible. Of course, sometimes you can't, right? Sometimes factoring just isn't possible. And let's talk about vertex form. So the first thing we'll do, we will go back to standard form. So to go to standard form, expand. Put my comma in there. I don't know if it's an appropriate place for a comma or not. And so to do this, first double up the brackets, then FOIL, then multiply through the new brackets by A, then collect like terms. To go to factored form, we don't really have a great way to do this. So there are 2 options. This isn't something we would normally want to do. So you could expand and then factor, or you could solve for x to get the zeros, then write in factored form with the A value being the same. And I'm going to do examples of all these, so if you're like, what is happening? I will show you what's happening. Factored form, so to go to standard form, expand. I'm not going to expand on how to expand. You should know how to do that. And if you don't, just get in touch with me. To go to vertex form, I'll say step 1. Go halfway between the zeros to get the axis of symmetry. Sub in the axis of symmetry to the original equation, and simplify to get the y value of the vertex. Cool. I think that will do it for all those things. Make the font size a little bit bigger, and maybe shrink this up. Maybe I made it too big. I made the font size way too big. Let's shrink it back down. Hope you're enjoying sound effects. They're a very important part of this. Oh, no. I didn't need to do that. Yeah, because that's the end of that. Okay. Sorry about this, folks. I thought it was all one table, but I forgot that I split them up. So I can actually make all these font sizes a little bit bigger here. And then I'm going to bring it into the file. Okay. This would be a good opportunity to try out the 2x feature, so you don't have to watch me edit all this. All right. I found a new tool, by the way. This is very cool. If you have a Windows keyboard, which a lot of you probably don't, but if you do, you hold Shift, the window button, and S, and then it brings up this tool. This is kind of like the thing I always do in class, where it makes that like shotgun sound or that camera sound. And then you can you copy it, and then if all goes as planned, I should be able to paste it, and there it is. So it's just like my little camera tool that you've seen before. But you should all have this tool on your keyboard. So again, it's Shift, window button, S, and then you can drag over the area that you want to take a screenshot of, which is kind of cool. It's like print screen, but you can select the area. So I like it a lot. All right, so there's that table. Again, you can pause it right now and copy stuff down. And hopefully everything in there was correct. So let's move on here. So I'm going to go back to the Word document again. And so what we're going to talk about now is sort of what you're being asked for any given question. Okay, so I give you lots of different questions, and I'm not always just saying like find the vertex. I'll say find the maximum, or find the break-even points, or find the roots, or whatever. Or find the number of zeros, or the number of break-even points. And I'm going to go through here, and again, this will be a really handy thing to have this year, but also next year. And we're going to talk about sort of what it's asking you in terms of basic parts of a parabola, and then how you find each one. All right. So let's first go just across this whole row. We'll do a row at a time. So if I'm asking you for the maximum or the minimum or the highest or the lowest profit or height or whatever, you are being asked for the y value of the vertex. And this is really important because when people read one of these questions, they're like, oh, I'm being asked for the vertex. Well, you're being asked for the y value of the vertex, and that's it. It would be a great idea for you. This would be an excellent opportunity to pause and try to fill this in on your own. And this will tell you where you're at in this unit. Because again, this is sort of a recap or a review. I'm not teaching you this for the first time. So if you have no idea what any of these things are, you might want to go back to the earlier lessons. So I encourage you to pause and at least fill in the rest of this row. And then if you need to unpause to get sort of each of these, that's fine. But you should be pausing and thinking about each of these, okay? Because I'm not going to be telling you what to do in every question. You're going to kind of have to figure it out for yourself. Okay. So in standard form, how do you find the y value of the vertex? You complete the square. And then look at the k value. Okay, so completing the square takes you to vertex form, and then you would look at the k value. In factored form, you add zeros, divide by 2, to get AOS, then plug AOS into the equation, and that will give you the k value. In vertex form, it's the last number. It's just k. K. All right. Number of items, customers, seconds, tickets required to reach the optimal / maximum / minimum. Okay, so if I'm saying how many items do you need to reach the max, well, that is the x value of the vertex, or the axis of symmetry. In standard form, again, pause and try this out. In standard form, complete the square, then look at the h value. In factored form, add zeros, divide by 2. And in vertex form, it's the number in brackets. Opposite sign, remember, if it's positive, it's negative, if it's negative, it's positive, for the h value. Okay, next, the value of break-even points. When something hits the ground, when something reaches a certain value, solve I've made air quotes there. You could probably tell by the inflection of my voice. Find the roots, the solution, blah, blah, blah. You're being asked for the zeros. Please pause and fill this in. Okay, in standard form, you have two options. Option one, factor it. That should be your go-to. It is by far the most important skill you picked up in this course and the skill that will be called on the most moving forward into next year. If you can't factor it, quadratic formula is a good option. In factored form, the zeros are in the brackets with the opposite signs. And in vertex form, I think the best way here is to solve for x after setting y equal to 0. So you set the equation to 0 and then you solve for x. All right, next, the number of solutions, roots, break-even points, times, or the number of times / number of times the relation reaches a certain value. This is the number of zeros. In standard form, look at discriminant. That's a hard word to spell. If it's greater than 0, 2 zeros. If it equals 0, 1 0. And if it's less than 0, 0 zeros. Okay, in factored form, if two unique sets of brackets, 2 zeros, two identical sets of brackets, 1 0. And if there are no zeros, there is no factored form. It doesn't exist. In vertex form, so remember this is sort of like the A and K thing. If A and K have the same sign, 0 zeros. If A and K have opposite signs, 1 0. If K equals 0, sorry, if A and K have opposite signs, that should say 2 zeros. I made a mistake. If K equals 0, there is 1 and 0. That's yesterday's lesson. If you have never heard this before, you really need to go back to yesterday's. Okay, let me just tidy this up, put some periods here in axis of symmetry. Boop, boop, boop. Still doesn't like it, but I will add it to the dictionary. All right. Now, let me shift window button S and copy this. And paste it in. And make it nice and big for you to pause it and copy it. I'm hoping you got a lot of that on your own. And if I made a mistake, please tell me. It's very possible. It's a lot of stuff being covered in a short time. And as you might remember from class, I make mistakes all the time. So usually you guys are there to catch me, but when we're not live, you can't. So let me know if I made a mistake and I will tell everybody else. Okay. Lastly, on your problem-solving guide is the transformation, sort of graphing style. So the basic parabola, y equals x squared. The vertex is 0, 0, and the step pattern is 1, 3, 5, which is over 1 up 1, over 1 up 3, over 1 up 5. And transform parabola. So if a is less than 0, so that means if a is negative, we say here reflected about or over the x-axis. Some people say flipped upside down. That's technically fine, I don't care. If the absolute value of a is greater than 1, so this is like 2, 3, or -2, -3. These signs mean absolute value. You don't need to worry too much about that right now. This is a vertical stretch. And by a factor of a, if blah, blah, blah. So now the absolute value, so this is like 0.5 or -0.5. And this is a vertical compression. Again, the absolute value just means ignore the sign, basically. And then if k is greater than 0, then it's been vertically shifted up by k units, or vertically shifted down k units if k is negative. If h is greater than 0, remember that would be like x minus 2. So x is actually positive here. Sorry, h. H would be 2 here. And then it would be horizontally shifted right if h is positive, and again if h is positive it looks negative in the brackets, or horizontally shifted left if h is negative. Okay, so that is the problem solving guide. Now what I'm going to do is I'm going to go back to the same table, and where I filled it in, I had meant to do an actual example. So I'm going to go back to the table, and we're going to do each of these examples here, and then that'll be it for today. So let's go to my notebook file, which has disappeared on me. This is it, I guess. This is it. Okay, and we are going to, right here, copy and paste it, and we'll go back to here, and I'm going to do each one of these examples here. Okay, so what I'm going to do first is I'm going to take the standard form, I'm going to change it into vertex form, and I'm going to change it into factored form. Okay, so to vertex form. And to do this, we complete the square. So the first thing we do is we take out that negative. So x squared plus 4x. Remember, we just divide the first two terms by the a value. In this case, it's just -1. So negative, and now we're going to have x squared plus 4x. And then we divide, so 4x divided by 2 equals 2x. Just forget the x. 4 divided by 2 is 2. 2 squared is 4. So we add 4 and subtract 4 and then add 3. Again, this is review, so if you don't know what I'm up to here, you should go back and watch the lesson on completing the square. I factored the first three terms. It's a perfect squared trinomial, which is what I want. Now the negative hits the -4, and we get plus 4 plus 3, and we get y equals x plus 2 squared plus 7. And that, if I did everything correctly, should be the vertex form. Now we will go to factored form. And to go to factored form, we first factor out the -1 again, and then we get x squared plus 4x minus 3. And now we need two numbers that multiply to -3 and add to +4. Two numbers that multiply to -3 and add to +4. So -3 plus 1 plus 3 minus 1. I cannot come up with a way that this is going to factor. So I think that means that the zeros must be bad. So we've got -x squared minus 4x plus 3. Yeah, those are nasty zeros. So this isn't going to factor. So if it doesn't factor, how do I change to factored form? Well, what we could do is we could just find the zeros. So let's erase this. And we'll find the zeros. So x equals -b, or +4, plus or minus the root, b squared. is going to be negative 4 squared, which is 16 minus 4ac, all over 2a, which is negative 2. So x equals 4, plus or minus. This is going to be 16 plus 12, I believe. So negative 4 plus or minus the root of 28 over negative 2. So x equals, so 4 plus the square root of 28 divided by negative 2, approximately negative 4.65. And 4 minus the square root of 28 divided by negative 2, and we get 0.65. So we can't really write this in factored form. I mean, we could, but it would be really ugly and it would have like radical signs and stuff. So what I'm going to say here is we could say that y is approximately, and then we put the a value out front, and then it's going to be x plus 4.65 and x minus 0.65. And so if we go into Desmos, let's check this. So y equals negative 1, x plus 4.65, x minus 0.65. And if you look here, if I turn this on and off, it lays right on top, but I would bet if I got in close enough, yeah, see? It's not perfect. If you really, really zoom in there, it's not perfect, but for our purposes, it's close enough. I don't think we're going to be building anything that comes down to that sort of margin of error. So really, you wouldn't write this in factored form because it doesn't factor, but you can take the zeros and put it in factored form just the same. Okay, next, vertex form. So first we will put it to standard form. So to standard form. And to put it to standard form, first we double up the brackets. And we get x squared plus 6x plus 9 minus 1. And then we get y equals 2x squared. I'm just multiplying through the brackets. And then plus 18 minus 1 is plus 17. Okay. And then if we're going to go to factored form, we are just going to solve for x. So to factored form, we need to find the zeros. And I think the best way here is to set it equal to 0 and solve for x. So we bring the negative 1 over. It becomes positive 1. We divide by 2 on both sides, and that 2 disappears. And now we take the square root on both sides. So we got to take the square root of 0.5. Ugh, 0.707. So 0.707 equals the square root of x plus 3 squared is going to be plus or minus, right? No, so the square root of this is plus or minus 0.707. And the square root of x plus 3 squared is x plus 3. So we get x equals 0.707 minus 3. So 0.707 minus 3 is going to be negative 2.29. Or 0.707, negative 0.707 minus 3. Negative 3.7. I guess we're going to 2 decimal places. Negative 3.71. So again, just like the last one, going into factored form isn't awesome. So let me see here. We've got y equals 2x plus 3 squared plus 1. Did I do that correctly? Nope, minus 1. Minus 1. We go home. And my zeros are negative 3.707 and negative 2.293, which is exactly what I have. So then we could say y equals, we got our a value is 2, and then x plus 2.29 and x plus 3.71. Again, you wouldn't really put this in factored form, but if you were asked for the zeros, you would have the zeros now at least, which is something. And let's try that. Y equals 2, x plus 2.29, x plus 3.71, and there you go. It lies right on top. But again, because we rounded, if you go in far enough, you will see that the curves are actually different. All right. Last one, we got a standard form, and we're going to first go to vertex form. So 2, we got factored form, we're going to vertex form. So we need the zeros. X equals 3 and negative 2. So the axis of symmetry is going to be 3 minus 2 over 2. 3 minus 2 is 1, divided by 2 is 0.5. And then the y value of the vertex is going to be negative 5. And then we sub in the axis of symmetry. And we get negative 5. 0.5 minus 3 is negative 2.5. And 2.5, again, we like that. That tells us that we're on the right track. And then we've got 2.5 times 2.5 times 5. 31.25. We got two negatives, so they cancel out. So 31.25, which means that y equals a, which is negative 5, x minus 0.5 squared plus 31.25. Okay, last thing, we're going to go to standard form here. And to do that, we are first going to FOIL. So x squared plus 2x minus 3x should be minus 1x minus 6. And then we multiply through the brackets. Negative 5x squared plus 5x plus 30. And hopefully I did everything correctly. I may have made a small mistake. But I think in general the steps I took are correct, and that's what's important here. Okay, so that's it for me. It's been 33 minutes. This is a particularly long one, but it is kind of combining like the last 3 or 4 units into one day. So this is going to be a big test. So let me just go through the problems that I'm going to have you do. The solutions will be posted later on. So Lila is creating dog runs for her dog kennel. She can afford 30 meters of chain link fence to surround 4 dog runs, and you can kind of see the image here. The runs will be attached to a wall, which means this wall, you don't need fence there, to achieve the maximum area. So when you see maximum, you should think vertex, the y value of the vertex. What dimension? So you need a quadratic, right? So first, let's redraw the diagram. So it's got 1, 2, 3, 4, 5 lines there, like so. Okay, and we can imagine that this whole thing is a rectangle. So we can put like a dotted line here, but we don't actually need material for that. So what dimension should she use? Well, what we're going to do is we're going to set this equal to x, which means this is x, this is x, this is x, and that's x. Okay, so I just want to get you started. This is probably the hardest question, and I know students will struggle, and it's the first question. I don't want people to give up. She's got 30 meters altogether. So you don't need chain link up here, but you do need it down here. You start with 30, but you've used 1, 2, 3, 4, 5 x's. So the length of this is going to be 30 minus x. The area is the width times the length, or the length times the width. So it's x times 30 minus x. And now you would find the max area. So you would find the vertex of this parabola. There are a lot of ways to do this. The best way for me, you don't even have to expand. Okay, and they're asking for the dimensions, so you need to find this x as well as this 30 minus 5x. Oof, jeez, I almost missed the 5. I hope some of you caught that. 30 minus 5x, because there's 5 x's. So expand this if you want. I'm going to tell you, though, you don't need to expand it. In this form, this is like kind of like factored form. So anyway, do whatever you want, find the vertex. And right, you want to find the vertex, it's the max value, or solve for x, right? Whatever you think. Okay. B, number 2. Using this model, what was Ontario's population in 1925? Notice this starts at 1900, so x equals 25. Sub it in, pretty easy. When will it reach 15 million? So notice this is in hundreds of thousands. So population, so how many hundred thousands are in 15 million? So 15 million divided by 100,000 is 150. So P equals 150. Put it in here, bring it over, and solve. And remember, in quadratics, solving means factoring or quadratic formula. This is pretty nasty. I would be surprised if it could be factored, but you never know. Try dividing by 0.007. For number 3, Richie walks diagonally across a rectangular field. He then returned to his starting position along the outside of the field. The total distance he walked was 36. So let's see here. So we've got a rectangular field. So he walked diagonally, so 15. This is 15. Then he returned to his starting position by going around the outside. So basically he followed this triangle. The total distance he walked was 36 meters. Okay, so let's say that this is x. We always need an x, right? We always need a variable. So if the total distance was 36, then the length of this side would be 36 minus 15 minus x, right? Which would be 36 minus 15 is 21, I think. 36 minus 15 is 21. So this side would be 21 minus x. And then this is a right angle. So you need your old friend, the Pythagorean theorem. So we're going to have x squared plus 21 minus x squared equals the hypotenuse squared. And then you can imagine expanding and foiling and collecting like terms and then solving for x. Again, I'm just getting you started on these. A diver was practicing his 10-meter platform dive. So, starts at 10, goes up and dives down to the water. Maximum height was 11.25. After 0.5 seconds, how long was he above the water after he dove? So you want to find this. Okay? All right. Garden area width. If the area of the walkway must be 900, so 900 equals 160x plus 4x squared. Right? I just subbed in 900 right there. And now solve for x. 6. Okay, this came up in the homework. Again, you don't have to watch all this. You can just try it first and then come back for hints. The points of intersection. So we want to know when this y and this y are the same. So we set them equal. Get everything to one side and solve. Max height, oh, that's easy. When did it hit the ground? Find the zeros. When did it reach a height of 80? Set h equal to 80 right here. Bring it over and solve. Okay. Currently, looking at the profit for last several years, notice the maximum average profit. So this tells you a part of the parabola, right? If this is the max, what does that tell you? Currently, with this and this, they have an average profit. Ticket price 20, profit is 6,300. Create an equation that shows the profit. Okay, so this is a solve for A situation. You have the vertex, you have a point, solve for A. Solve by any method. Just be sure here that you like FOIL and multiply through. And here you got to multiply through, you got to FOIL. Bring everything to one side and solve. Complete the square, you should be able to do that. For what values of k would it have exactly 1? So I'm just going to tell you b squared minus 4ac equals 0. And then solve. All right, he has written the relation. This is the perimeter. He has 72 meters. What dimensions will maximize the area of each cubicle? Okay, so he's got 72 meters. Okay, so we want the area of each cubicle. Okay, so area of one cubicle is length times width. That's the equation that we're using here. So we want to know, we got to express L or W in terms of the other. So here's my hint. 72 meters is what he's using altogether. The total length of cubicle wall needed. So I think that's all these walls combined. Okay, so we can say 72 equals 9L plus 10W, right? Because 72 is kind of the perimeter. That's kind of what we're talking about here. And now we would just solve for one of them. So I'm going to solve for L. So 9L equals 72 minus 10W. Divide everything by 9. L equals 8 minus 10 divided by 9. Oh, that's nasty. Let's do it the other way. Let's try it the other way. Let's rearrange for W. 10W equals 72 minus 9L. W equals 7.2, and then 9 divided by 10, that's better, minus 0.9L. So maybe we do this. Area equals length times width, and width is 7.2 minus 0.9L. I think that's a good starting point there. And then you want the dimensions to maximize. Maximize means find the vertex. Is that the last question? It is. And there's some homework. So this will keep you busy until the start of next week. So I've got you started on most of these 12 questions. I'll post the solutions at the end of the day today or tomorrow. I'm not sure yet. But I'll post them, and then you can work on the homework as well. Okay, folks, good luck, and reach out if you need some help. We're sort of at the end of all the quadratics, so you need to know a lot of stuff right now, which is going to make this, it's difficult. And if you haven't been really keeping up, it's going to be a particularly difficult time. So make sure you don't slack off now. This would be a good time to take some time and get caught up before the test gets posted on Tuesday of next week. All right, good luck.